In this question, you already have two forces, 5 Newton and 10 Newton acting on the square wooden plane, which is pivoted at the center O. So you can see this is like a top view. So the first thing you need to know that is that this 10 Newton force is going to create a clockwise moment, and this 5 Newton force is going to create a anti-clockwise. And then the question asks which of the following condition will keep the square plane in equilibrium, that means balance. So in other words, the net moment, it has to be 0. So that means to say initially this setting right now, the object is not in equilibrium. You cannot use anti-clockwise equals to clockwise to solve this question. So rather we will do separately the anti-clockwise moment, which is by the 5 Newton, it will be force times the distance. Now, for a distance, since it's mentioned that it is a square, that means they have equal side. To make things easy for me, I'm going to assume the one side, each side is 2 units. Okay, so like that, here to here will be considered 1 unit. All right, so 5 times, do you remember the line of action of the force is here, and this should be the perpendicular distance that I should be using. So it's just 1 unit, 5 Newton. Let's assume it's meters, 1 meter. So then the clockwise moment will be 10 times. Once again, this is the line of action of the force. The pivot is here. This will be the distance that I use. So likewise, it's still 1 meter and it will be 10 Newton meter clockwise. So we can see that there's a net clockwise moment. 10 minus 5 will be 5 Newton meter, and there will be a net clockwise. This thing will turn clockwise due to the 5 and 10 Newton force acting as it is right now. So now what's another force? You just need one more force in order to keep it in equilibrium. All right, so firstly, let's eliminate one of the option Q first, because Q will not create the moment. And what's the reason? Because the line of action of the force passes through the pivot point. There's no perpendicular distance, no moment created. So Q definitely, if you apply a force in that position, in that direction, it will not cause the square wooden plane to actually rotate. So Q is out already. So, and since another thing to take note is, since right now there's a net clockwise moment, the force that you need to apply must be anti-clockwise. This is what is needed. Anti-clockwise, and the magnitude must be 5 Newton meters. So if you look at the pivot here, the only way to create an anti-clockwise moment is by P in this way. This will create anti-clockwise, not R, because R will be creating a clockwise moment, which you do not need. So in other words, R will be wrong also. So you need left with P, and what is the force that is required? Because if you look at the position of your P, the line of action of the P is here, and the pivot is here. The perpendicular distance likewise here will be 1 unit. All right, so it's to get a magnitude of 5 Newton meter, that's 1 meter times 5. So P, and then the force has to be 5 in order to achieve 5 Newton meter anti-clockwise. All right, so the answer will be A.